Hi all, today we are going to see file management in OS. From the user's point of view, one of the most important part of OS is file management. When we talk about file management, few things come into our mind. The first one is how we are going to save a file. The second one is what all the operations can be performed on a file. And the third one is how we are going to organize a file. Let's have a look at file management system in OS. As I said earlier, file system is one of the most important part of the OS. Data collections created by users is also known as files. We have three desirable properties of files. First one is long-term existence, second one is shareable between process, and the third one is structure. Long-term existence means files are stored on disk or other secondary storage devices. Second one is shareable between process. It means files have controlled sharing between processes. Structure. File can be organized into structure to reflect the relationship among files. What is file system? File system stores data as organized files and it is a collection of functions, that means operations. Now let's see file operations one after the other. First one is create. We can able to create a new file. Second one is delete. We can able to delete a file. Third one, open. We can able to open an existing file. Fourth one, close. The file is closed with respect to a process. Fifth one, read. A process reads all or a portion of the data in a file. Sixth one, write. A process updates a file either by adding a new data that expands the size of the file or by changing the values of the existing data items. So what are all the file operations we are having? Create, delete, open, close, read and write. Next one we are going to see is file structure. There are four terms commonly used when discussing about files. They are field, record, file and database. Field. It is a basic element of data. It contains a single value and it is of fixed or variable length. Second one is record. It's a collection of related fields. One field is the key field. Third one is file. A collection of similar records treated as a single entity. And the last one is database. As we all know, it's a collection of related data and it also depicts relationship among elements of data. So what are all the four elements in file structure? Field, record, file and database. Now let's see database operations. So we have retrieve all, retrieve one, retrieve next, retrieve previous, insert one, delete one, update one, retrieve few operations in database. Retrieve all means we can able to retrieve all the records of a file. Retrieve one, from the name itself we can say that we can retrieve only one record. Retrieve next. It means it will retrieve the next record in some logical sequence. Retrieve previous, it will retrieve the previous record in some logical sequence. Insert one, we can able to insert a new record into a file. Delete one, it will delete an existing record. Update one, it will update one or more of its fields. Retrieve few, it retrieve a number of records. Now let's see file management user requirements. User can able to create, delete, read, write and modify files. User may have controlled access to other users' files. User may control what type of access are allowed to the files. User can be able to restructure the files. User can be able to move data between files. User can be able to backup and recover files. Should be able to access his or her files by name. For example, test, new, like that. Next, we are going to see file system architecture. That is how a user program is communicated with the lower level hardware. We have 5 layers in this file system architecture. The first one is file format. So this one contains file, sequential, indexed and hashed files. The second layer is logical I/O. Third one is basic I/O. Fourth one is basic file system. And the last one is device driver. Let's see one after the other. Logical I/O. This level is the interface between the logical commands issued by a program and the physical details required by the disk. That is, it is the interface between the program and the disk. It enables the users and applications to access records. Second one is basic I/O supervisor. Supervisor means it will supervise something, right? So it is responsible for all file I/O initiation and termination. Scheduling, file status are maintained by basic I/O supervisor. It selects the device on which the I/O is to be performed, and it is responsible for optimized performance. That is, the performance is decided by the I/O supervisor. The third one is basic file system. We can otherwise call this as physical I/O. It deals with exchanging blocks of data, concerned with the placement of blocks. That is, where we have to place this block. Everything will be managed by basic file system. Device driver. These are all lower level drivers which communicates directly with the peripheral devices. It is responsible for starting I/O operations on a device. It processes the completion of I/O request. The next we are going to see is file organization. File organization is the logical structuring of the records as determined by the way in which they are accessed. This logical structuring is coming here, that is here. So file, sequential, indexed, hash, these are all logical structures. Let's see one after the other. Right. So these are the logical structures. First one is file, second one is sequential, third one is index sequential, fourth one is indexed, and the fifth one is direct and hashed file. First, let's see file. First, look at this picture. Here, every record is arranged one after the other, and it is of variable length and variable set of field and chronological order. So it's the least complicated form of file organization. Data are collected in the order they arrive. Purpose is simply to accumulate the mass of data and save it. Because there is no structure, record access is by complete search. That is, when we want some file, we have to search the entire thing. That is, entire files, we have to search it and we have to get that particular file. The next one is sequential file. From the name itself, we can say that it is sequentially accessed. That is, it is of fixed length record, fixed set of field, but it should be accessed sequentially. That is, one after the other. So most common form of file structure is sequential file. A fixed format is used for records. Key field uniquely identify the records and determine storage order. Used in batch application. The next thing is, when a new record is placed in log file or transaction file, periodically it will merge to master file. That is, when a new file is created, it will be in the log file or transaction file, but periodically it will be merged to the master file. The next one is index sequential file. In index sequential file, we have one index and the next one is main file and the other one is overflow file. So index is just like our book page index. So it will refer the main file. From the main file, it will refer the overflow file. That is, when a file is newly created, it will be in the overflow file. Then it will be added to the main file. Records are organized in sequence based on the key field, and it supports random access by using index and overflow file. Overflow file is similar to our log file. It is easily located by the pointer. Index file consists of two fields. One is key field and a pointer to the main file. Each record in the main file have an additional field, a pointer to overflow file. It reduces the time required to access a single record. Index file. So in index file, we have two indexes. One is exhaustive index and another one is partial index. Exhaustive index is connected to every record, but partial index will be connected to the desired record. So we can have multiple indexes. Records are easily accessed. Variable length records can be employed. Exhaustive index contains one entry for every record, and partial index contains entries to record where the desired field exists. So we can use this index file in airline reservation system and inventory control system. The last one is the direct or hashed file. From the name itself, we can say that we can directly access any block of known address. It uses hashing technique to fetch the files. Examples are directories, pricing tables, schedules, and name lists. The next one we are going to see is file directory. File directory contains information about the file, including attributes, location, and ownership. We have several operations that can be performed on a directory. What are they? First one is we can search a file in the directory, we can create files in a directory, we can delete a file in a directory, list directory, and we can able to update directory. Now let's see the elements of a file directory. Basic information. It consists of file name, file type, and file organization. File name, example, new, test, class 1, class 2. File type, example, text, binary, image, audio, video, etc. File organization, file, sequential, index, etc. Address information. It consists of volume, starting address, size used, and size allocated. Volume. Device on which the file is stored is known as volume. For example, whether the file is stored in hard disk or it's stored in the pen drive, etc. It is mentioned here in the volume. Starting address. The physical address of the file is stored in this starting address. Size used. Size of the file. For example, 1 MB, 2 MB, etc. Size allocated. Maximum size of the file. The next one is access control information. Who is the owner of the file? And access information, that is whether the file is having username or password, and permitting action like read access, write access, read only access, like that. Usage information, date created and identity of the creator. Date last read access and identify the last reader. Date last modified and identify the last modifier. Date of the last backup and the current usage or logged by a particular process. When we talk about file, we have to talk about the file sharing also. When we share a file, we face two issues. One is access rights and another one is simultaneous access. Access right means we are giving some permission to the user. We have so many access rights for a file. One is none, second one knowledge, third one execution, reading, appending, updating, changing protection, and deletion. None. User would not be allowed to read the user directory that includes the file. Knowledge. User can determine that the file exists and who is owner of the file and can then petition the owner for additional access rights. Execution. User can load and execute a program but cannot copy it. Reading. User can read the file for any purpose, including copying and execution. Appending. The user can add data to the file but cannot modify or delete anything. Updating. User can modify, delete, and add to the file's data. Changing protection. User can change the access rights granted to other users. Deletion. User can delete the file from the file system. The next one is simultaneous access. User may lock entire file when it is to be updated. User may lock the individual record during the update. So when we talk about the simultaneous access, we have to take care of mutual exclusion as well as deadlock issues. Hope you all enjoyed the session. Have a good day.